This is problem 19 in chapter 3, and I just wanted to go over it again today. I think at the end of the period, just so people are clear. So the idea here is that I'm going to use Newton's second law, which says sum of the forces is, in this case, big MA. That's the equation I'm going to use. As it gets implemented, it looks like lift minus big mg is equal to big M, and then I'm going to put minus A in there because in the first case it is descending downward. Once I remove some of the mass, I now have my lift force doesn't change, but my downward force now looks like big M minus little m times g, and my acceleration is upward. So that's going to look like L minus, and I'm going to break these out just so I don't mess myself up, L minus mg plus little mg is equal to big M A minus little ma. And I broke those out like that just so that it would, so that it would be just a little bit more straightforward. So in essence, this term here is the downward force, and this term here is just the acceleration. Now what I want to do is eliminate lift from both of these equations. And one way to do that is just to subtract one equation from the other. So what I'm going to do is I'll bring down this equation here, and I will subtract them. So I want to make this one negative. So that's going to be minus L plus big mg is equal to big M and then A. And the A now goes positive because I subtracted, I changed the sign. So when I subtract this from that, the L's are going to cancel out, the big mg's are going to cancel out. I'm going to be left with little mg is equal to 2 ma minus little ma. So again, we'll remember we're trying to solve for how much mass is thrown out. So I'm going to rewrite this equation as mg plus ma is equal to 2 big M times A. I'm going to write this as M times G plus A is 2 big M times A, or M is equal to 2 big M A over G plus A. And that's the correct result. So again, the key pieces here were I carefully defined the direction of my acceleration. One was positive, one was negative. In both cases, I said the sum of the forces are equal to MA, and then I was able to just take this one, take the top equation, make it negative, subtract one from the other, and I got the result that one would expect.